Yep. Tiger 9-1. Tiger 9-1, Roger. Anchor 26 track, 035.
This is a companion video to the one I just did about a modified case tumbler used to improve my brass sorting process, and I wanted to get this video out to answer the questions that I'm no doubt going to get about the foot pedal and the solid state relay that I used in that, and wanted to head off a bunch of questions. This should be pretty quick. So let's take a closer look at the solid state relay we have here. This is a simple relay box that I had already had wired up, except that it had a timer switch in it. It's connected to a small battery pack here, and then off to the foot switch. Here we have the solid state relay attached to a chunk of aluminum that is just used as a mounting point, but it also helps bleed any heat off of the SSR that might build up, although there's really not going to be much since this relay is not going to be on in any kind of continuous duty. So here we have a basic solid state relay. This is actually let's take a closer look. This is a gold brand. This is more of an eBay kind of brand rather than a main top-of-the-line one like an Omron. But this is a gold SAP 4825D. Let's take a closer look at that device. So here we have the SAP 48 series and its data sheet. Let's get see if we can zoom that a little bit. Now we're talking about a 4825D, so that puts us right here with the DC. That means it's a 32 to 30 volt input trigger in DC, and that it supports up to 25 amps. Well, that's pretty good. That's certainly more than I really need for this approach. And again, here's how you can decode those numbers. Taking a quick look in here, this will operate at up to 530 volts AC. Not a whole lot of other really interesting information maybe in this. Let's take a look at the input specifications. Okay, it says that 3 volts, that we need 3 volts in here to power it, right here. And that minimum turn off is 1 volt. It looks like minimum turn on, maximum turn on current. There we go. Maximum turn on current is going to be 12 milliamps. That's not much. So this ought to work pretty well. Other information, I don't know if there's anything else of really any real interest in here. It has a little LED on it that indicates that it's received enough voltage to trigger. That's an input voltage LED. That's the input trigger. That has nothing to do with the outputs. That's just if the inputs have received enough power. So when the foot pedal is pressed, the little LED comes on right there, and I think my foot switch contacts are a little bit on the crappy side, so I'm going to have to maybe get in there and work on that a little bit. And I decided to run this off of batteries because it really just doesn't need that much power, and it's not like I'm going to run this relay 24/7. It just gets half an hour of use every couple of weeks to sort out brass. In fact, let's take a look at the power consumption for this. And to do that, let's drop out the batteries. And let's see what kind of battery life we might be able to expect. Let's hook up a power supply to it. All right, so we've now hooked our power supply in as to run the SSR. So let's turn it on, and let's see what kind of current it does. So if it does take it, we're at 3 volts. And I press that down. Okay, 8 milliamps. That's pretty good. I'm not getting very good click contact here. Here we go, 10 milliamps. All right, right in the range. So with a full set of batteries, it's going to work just fine. What I wonder is how will it go down very far on its power consumption here? So if I go down to, say, 2.6 volts, what's it eat? And again, these like I said, I didn't trust these contacts too much. 7 milliamps. Okay, that was its minimum according to the spec sheet. It may not work much lower than 2.6 volts. Let's go to 2.2 because that would mean a nominal voltage of 1.1 volt out of each battery, and that's about as low as you can run a AA battery. And it's saying 3 or 4 milliamps. Oh, there we go. So, like I said, these contacts, I don't trust them. 5.8 milliamps. Yeah, that's plenty to turn on the turn that on. I think. Let's take a look back at the relay and see. Does it look like that's going to do the job? Yep. Sure enough, I click it at 2.2 volts, and the LED comes on pretty good. So that should probably run the tumbler all the way down. So that's going to give me close to 2,000 hours of battery life out of a pair of AA's. So, all right. Sometime after the year 2020, I'll probably need to replace these, about the time they expire. There's not a lot to talk about on these SSRs. They're really quite simple. Here's an example of the gold SSRs. These, like I said, these are just kind of an eBay brand. They do cost quite a little bit, though. They're not the cheapest. I just happen to have it laying around. There's $32. I'm not sure that's really a good price for it, but it's been a reasonable brand for me to use. You can find these elsewhere, like at MPJA. They sell all sorts of stuff, and again, it's also very similar quality usually to the eBay stuff, at least from what I've found. And here's a much lower price, $6 if you're US. And this relay, I don't really know much about this Hoymk, H-O-Y-M-K manufacturer. I've not used these SSRs, so I can't speak to their reliability, their quality, whether they have really good AC, isolation across from the low voltage into the high voltage sections. But you can find these all over the place. They're pretty common. And for those interested, here's the basic circuit that we have going on. So we've got the foot pedal, the battery pack. So you just close the loop, and then here's your galvanic isolation is right here, and that's going to protect you from the other side. So then on the AC side we have the this is the wall outlet right here, and then that feeds into the relay on the hot side through the relay, and that's it. So you hit the switch, tumbler starts up, done. So anyone has any questions, that's how it's hooked up. There's just really not all that much to this. So, in short, that's really all there is to this tumbler thing. The foot switch, hopefully that answered the questions of how to wire it up. If you're interested, try to do this in a very safe manner. This is AC. It can be dangerous. You want to make sure that you have good solid connections. In fact, I'm seeing a little right here, little copper kind of peeking out. It's probably pretty safe because I have grounded the enclosure, and I used very strong strain reliefs here to keep the to protect the connections inside. So do a thorough job of it. If you're not confident, find someone who can. I wouldn't advise anyone to mess with AC unless they really understand what they're doing, and really probably should be licensed. Hopefully that answered your questions. Maybe somebody else will come up with something a little more interesting on this, another variant. I'd love to learn from your version of what you came up with. Let me know in the comments.